Despite its widespread acceptance, it struggled to address some key issues. In recent years, new research has added even more complexity to this cosmic puzzle. One of the most notable breakthroughs came in 2023, when NASA's James Webb Space Telescope made a groundbreaking discovery that has since sent shockwaves through the astronomical community. This discovery involved a celestial object that appeared to be older than the universe itself, an astonishing revelation that has left scientists both baffled and intrigued. The idea that such a star could exist for a longer period than the entire known age of the universe challenges some of our most fundamental scientific assumptions. This revelation has prompted astronomers and cosmologists to question how, in any conceivable model of the universe, a star could predate the universe itself. Could this discovery challenge our current understanding of the cosmos? Might it even require the conception of a completely new cosmological model to make sense of such an enigma? These are just a few of the many questions that have arisen, and they are questions that we aim to explore in this video and beyond. If you're interested in staying informed about news from the universe and beyond, from mysterious ancient stars to revolutionary new theories, subscribe to our channel, like this video, and be sure to turn on the notification bell so you never miss an update. Let's delve deeper into the details of this perplexing discovery. About 200 light-years away, near the constellation Libra, lies an ancient star known as HD 140283, sometimes colloquially called HD Waltino 283. What makes this particular star especially intriguing is not just its advanced age, but its surprisingly high velocity, which is clocked at an impressive 44,283 km per hour. This velocity offers valuable clues about its dramatic past and its unique position in the timeline of cosmic history. Scientists believe that approximately 1 billion years ago, during the early formation of our Milky Way galaxy, this star merged with a smaller dwarf galaxy. That smaller galaxy was likely the original home of HD 140283, and this galactic collision left an imprint on the star's trajectory and velocity. However, the most fascinating aspect of this star, nicknamed Methuselah after the biblical figure reputed to have lived 969 years, is not its speed, but rather its astonishing age. Initial estimates placed the star's age at a jaw-dropping 16 billion years. This figure immediately raised eyebrows, as it blatantly conflicted with the widely accepted age of the universe. More recent and refined measurements have revised that figure to about 14.46 billion years, with a margin of error of 800 million years. Nevertheless, this still presents a significant conundrum. The estimated age of the universe, based on detailed observations of the cosmic microwave background radiation, is around 13.8 billion years. The paradox of how a star can be older than the universe itself raises serious questions about the reliability of our dating methods and whether our current understanding of the universe's age is indeed accurate. Determining the age of celestial objects is an incredibly complex and nuanced task. Stars like our own Sun can maintain a relatively stable temperature and size for billions of years, making it exceptionally difficult to pinpoint their ages with high precision. Astronomers typically rely on subtle changes in brightness and color over extended periods of time. These changes are compared to mathematical models that predict how stars evolve as they age. One crucial indicator of a star's age is its rotation rate. Much like a wheel slows over time due to friction, stars also gradually slow their rotation. By comparing the rotation rates of stars of various ages, scientists have developed mathematical relationships to estimate stellar ages using a method known as gyrochronology. Methuselah is undeniably ancient. In fact, it is the oldest star in the universe for which we can reasonably estimate an age. Rather than simply accepting that it could be over a billion years older than the universe, scientists are beginning to consider alternative possibilities. Perhaps it is not the star's age that is wrong, but our assumption about the universe's age that needs revision. Could it be that the universe is older than scientists have previously believed? The possibility is both thrilling and daunting, as it forces a re-evaluation of long-held beliefs and data. It is difficult to fully grasp the immensity of 13.8 billion years. To put it into perspective, if we were to represent the universe's entire history as a single cosmic calendar year, with the Big Bang marking the most dazzling New Year's fireworks, then the Earth would only appear near the end of December. All of recorded human history would occupy just the final 10 seconds of December 31st. This mental model helps convey just how fleeting human existence is compared to the grand timescales of the cosmos. Scientists calculate the universe's age by observing light from stars formed hundreds of millions of years after the Big Bang. As the universe expands, it causes a redshift in the light of distant celestial objects. By analyzing both the redshift and the distance of these observable galaxies, researchers have estimated that the universe is about 13.8 billion years old. However, New findings from researchers at the University of Ottawa suggest that this may be a vast underestimation. According to their studies, the universe may in fact be much older, possibly around 26.7 billion years old. University of Ottawa physicist Professor Indra Gupta has proposed a bold and compelling theory to support this notion. His theory combines Swiss astronomer Fritz Zwicky's 1929 tired light theory with newer, contemporary concepts. The tired light theory posits that protons lose energy during their journey across vast cosmic distances and over long periods of time. Although this contradicts conventional interpretations of redshift, where redshift is considered evidence of cosmic expansion, Gupta suggests a hybrid explanation. In his view, redshift may be partially due to the expansion of the universe and partially due to the energy loss of photons over immense distances and timescales. This reinterpretation could significantly extend our estimate of the universe's age and offer explanations for both long-standing cosmological questions and recent, puzzling observations made by NASA. The James Webb Space Telescope, a marvel of modern engineering and scientific achievement, has played a key role in supporting this revised estimate of 26.7 billion years. The telescope's unprecedented sensitivity and range have allowed it to observe objects and phenomena that were previously out of reach, pushing the boundaries of our cosmic knowledge further than ever before. Gupta's model also incorporates the concept of the evolutionary interactions constant, a theoretical idea originally proposed by physicist Paul Dirac. This idea implies that fundamental interactions, such as gravity and electromagnetism, may have changed over time. This suggestion, if proven true, would have enormous implications. It could help explain the discrepancy between Methuselah's age and the age of the universe and reshape our understanding of physics as a whole. It's important to recognize that our estimates of the universe's age have been revised many times before. For example, in the 1920s, Edwin Hubble famously estimated the universe to be only about 2 billion years old. Over the past century, that estimate has been revised upward as our tools and understanding have improved. Gupta's new model represents yet another important milestone in the ongoing process of refining our cosmic timeline. Whether we view human history as occupying the final 10 seconds or even just the final 5 seconds in the grand scale of the cosmic year, one thing is certain: the universe is unimaginably old and filled with wonders that continue to reshape our understanding. The mystery of Methuselah is just one piece of a much larger puzzle that scientists around the world are racing to solve. In addition to these grand cosmic revelations, there have also been fascinating new observations within our own galaxy. Recent measurements suggest that stars in the outer regions of the Milky Way are moving significantly slower than expected when compared to stars in similar positions in other galaxies. This puzzling behavior has raised two intriguing possibilities. One possibility is that our galaxy may contain an unusually low amount of dark matter, the mysterious, invisible substance that is thought to account for much of the gravitational structure in the universe. The other possibility is even more radical: that our understanding of dark matter itself, including how much of it exists and how it behaves, may be fundamentally flawed. This ongoing conundrum is based on data collected by the European Space Agency's Gaia satellite. Gaia has provided astronomers with highly detailed positional and motion information for nearly 2 billion stars in the Milky Way. These observations have led scientists to reassess how stars move, especially in the outskirts of our galaxy. The speed at which stars move is a crucial clue in determining the total mass of a galaxy, because the gravitational force acting on each star depends on that mass. A recent study using Gaia data calculated that the Milky Way's total mass, including gas, dust, stars, and dark matter, is approximately 200,000 billion times the mass of our Sun. While this number is still staggeringly large, it is about 5 times less than previous estimates. This doesn't mean that visible matter has disappeared or was never there. Rather, it may suggest that there is far less dark matter in our galaxy than we previously thought. However, estimating the mass of an entire galaxy is notoriously difficult. This discrepancy could stem from uncertainties in the data collected by Gaia or in the new methods used for analysis. Despite these uncertainties, one thing is clear: the mystery is far from solved. Astronomers will continue to study these anomalies with the hope of refining our understanding of dark matter and the structure of the Milky Way. We will keep you updated with the latest developments as they unfold. If you found this video interesting and informative, don't forget to like and subscribe. And as always, we'll see you in the next one, where the universe never stops surprising us. The implications of the Methuselah star go far beyond a simple numerical discrepancy. If the universe is indeed older than 13.8 billion years, this opens the door to an entirely new paradigm in cosmology. It would force us to reconsider everything, from the timeline of galaxy formation to the behavior of fundamental particles over cosmic time. Perhaps most provocatively, it would challenge the very concept of the Big Bang as a singular beginning. Could it be that the universe has undergone multiple cycles of expansion and contraction, as some Big Bounce theories suggest? Or could there be parallel universes, with Methuselah being a remnant of a previous cosmos that somehow bled into ours? Some physicists have already begun to explore cyclical universe models, those that propose the universe undergoes repeated Big Bangs and Big Crunches in an infinite loop. In these models, the Big Bang isn't the beginning of everything, but merely the most recent phase in a far more ancient and complex existence. Methuselah could represent a fossil of such a previous epoch, a survivor of a prior cycle. Although speculative, such ideas are gaining traction, especially in the wake of data that doesn't quite fit into the standard model. Furthermore,